Hey, welcome back for another week. So our video lecture for today, it's going to be a little bit shorter than usual. We're going to be talking about this idea called percent composition. I've used this word composition before in class. Remember that it means what something is composed of, what goes into that substance or that compound, which elements, and how much of which elements. That's what we're going to kind of look at is how much of which element is in those compounds. So if we take a look here, like I said, sometimes it's helpful to know how much of a certain chemical or element is inside your compound. If your compound has a lot of chlorine in it, for example, you run the risk of releasing a bunch of chlorine gas when you do reactions with that compound. So just knowing how much of the element is in that given compound is going to be a helpful skill for us. These are typically done by percentage of mass. So it's based on the mass of the element and of the compound, and we're going by percentages. So what percent is carbon? What percent is oxygen? It'll be questions like that. If you're asked to find the percent composition of an element in a compound, what you're going to do is you're going to take the total mass of that element. You might have to multiply by subscripts if you have multiple atoms of that element inside the compound. But you'll take the total mass of the element in the compound, divide it by the mass of the entire compound. So that'll be the molecular mass. We've done problems like that. And then you're going to want to multiply it by 100% just to turn it into a percentage. You've already got your answer at that point. You just need to move the decimal point to make it look like a percentage. So I do have a formula down here. If I move myself out of the way here, the percent composition is equal to the mass of the element divided by the mass of the compound and multiply all of that by 100%. So if I'm looking for the percentage of an element in a compound, in the numerator, I've got just the mass of that element. Maybe it's the mass of all the carbon or the mass of all the oxygen, whatever the question is asking me for. In the denominator, underneath here, that's where I'm going to put the molecular mass of that compound, the mass of the entire thing, all of the elements and all of the atoms that are in that compound. And we've done problems like that. So you take the mass of the element, divide it by the mass of the compound, multiply it by 100%, and that'll give you the percent composition of the element in that compound. Let's take a look at some examples here, and then we'll switch it up a little bit. We'll go through these two examples on the screen, and then I'm very excited I get to show you my new whiteboard wall. We'll take a look at that in a second here. So let's look at this number one here, this first problem. What is the percent composition of carbon in C2H5OH? I know that this is ethanol, drinking alcohol. So what is the percent composition of carbon in ethanol? Well, I'm going to use that formula that I showed you on the last slide. On the top, in the numerator, I'm going to put the total mass of carbon. This compound has 2 atoms of carbon. So I'll look up the atomic mass of carbon with my periodic table. I know that that's about 12 atomic mass units. I'm going to take that 12 number that I got from the periodic table, multiply it by 2, because I've got 2 carbons in this molecule of ethanol. So 2 times 12, that's about 24. In the denominator, I'm going to put the molecular mass of the entire compound, not just the carbons, but all of the hydrogens and this oxygen as well, which is going to be about 46 atomic mass units. So if I've got 24 in my numerator and about 46 in my denominator, if I do that division and then I multiply by 100, I'm going to find out that this is just about 52.1% carbon. So ethanol, drinking alcohol, over half of it is carbon by mass. 52% of that compound is going to be composed of carbon. That's the percent composition. Let's try one more. I'll move myself out of the way here. So this problem, it says, what is the percent composition of aluminum in aluminum oxide? This formula here is aluminum oxide, and that's one that you should be able to name. Al2O3, aluminum oxide. So I want to know what's the percent composition of aluminum. I'm going to use that same formula. In the numerator, I'm going to put the mass of all of the aluminum. I've got 2 atoms of aluminum. In the denominator, I'm going to put the mass of the entire compound, the molecular mass, which I'll also have to get from the periodic table. If I do numerator divided by denominator, multiply it by 100%, I'm going to find out this time that the percent composition of aluminum in aluminum oxide is, again, about 52%, closer to 53%. So most of the aluminum oxide is made up of aluminum by mass. I've got 3 atoms of oxygen for every 2 atoms of aluminum, but aluminum is heavier. Aluminum has a higher atomic mass. So if I'm just going by the mass, the percent composition by mass, there's actually more aluminum, a greater mass of aluminum in this compound, aluminum oxide. So you can see how we use that formula, hopefully. We're going to continue to use that formula, and we're going to do a few problems right here on my whiteboard wall. And your homework tonight is also very short. It's only 3 of these problems. So again, I've been trying to cut it back for you a little bit, considering our e-learning, our distance learning here. So we're going to do a few problems on the wall here, and then you have 3 problems for homework tonight. Let's do it. So we're going to try something a little bit different today. Over this quarantine, my fiance and I did this little project in our office space, and we painted this wall with dry erase board paint. So now we can actually write on it with dry erase board markers and then erase it really easily. This is going to be sort of like my new whiteboard for these lectures and for office hours and things. So we're going to do a few problems here on the wall. And then we'll wrap up the video lecture for today. This first problem, it says, what is the percent composition of nitrogen in trinitrotoluene? So I'm looking for the percent composition of nitrogen in this chemical right here. Trinitrotoluene, this is actually TNT. TNT, it's an explosive. So I want to know how much nitrogen is in this explosive based on mass. I've got the formula for TNT also up here. C7H5N3O6. And then I also put the percent composition formula up here. You should definitely have this in your notes somewhere. The percent composition is equal to the mass of the element divided by the molecular mass, and then multiply all that by 100%. The best starting place for problems like this is going to be finding the molecular mass. That's going to be a really good starting point. You know that you're going to need it eventually for the formula anyways, so that's where I'm going to start. So looking over here, I have my formula for this compound, TNT. I would need to multiply these subscripts by the average atomic masses, which I would find on the periodic table. So for carbon, I've got 7 atoms of carbon. I know that each atom of carbon is just about 12.01 atomic mass units. So I'm going to do 7 times 12.01. I've got 5 hydrogen atoms, 5 hydrogens. Each one is about 1.01 AMUs. 3 nitrogens and 6 oxygens. Again, I'm getting all of these mass numbers from the periodic table. These are the average atomic masses. If I take all these and add them together, it's going to give me the molecular mass or the molar mass, depending on which unit I choose. I did this one in advance, and it looks like it's going to be 227.15. I'm going to go with the molecular mass. We'll call it AMU. If I had labeled this in grams per mole, then it would be the molar mass. Same number, different unit. So there's one part down. I've figured out the molecular mass of TNT. But for the formula, I'm also going to need to know the mass of just the element that we're looking for. The element we're looking for is nitrogen. So I'm going to use this part right here. These are my nitrogen atoms here. I've got 3 of them. Subscript is 3. I know that the average atomic mass of nitrogen is about 14.01. I got this from the periodic table. 3 times 14.01 is going to be about 42.03 atomic mass units. So now I'm ready to plug it into the formula and solve. Using this formula over here. My percent composition of nitrogen is equal to the mass of all of the nitrogen. I figured that out over here, about 42.03. We're measuring in atomic mass units. And I'm going to divide that by the molecular mass of TNT. And I actually already did this since that's what I started with. It's about 227 atomic mass units. 227, about 0.15. And I'm going to multiply all of that by 100%. That just changes it into a percentage. It's not actually going to change the value. It's just going to move the decimal point and give it that percent sign. So from here, I would punch this into my calculator. Make sure that we're doing order of operations here. So I really should have put parentheses here. But if I put this into my calculator, which I did in advance, but you can double check my work, it's going to be just about 18.5% nitrogen. So if we're looking at TNT here, a molecule of TNT, one molecule of TNT has 3 atoms of nitrogen, and that makes up about 18.5% of the compound by mass. So the best way to approach these problems, first, you've got to know what the actual formula is. What's the formula of your compound? Sometimes it'll be given to you. Sometimes just the nomenclature will be given to you and you'll have to find the formula. Once you've got that formula, I think the next best step is to find the molecular mass. We do this by using the periodic table and the subscripts. Then you need to find the mass of just the element that you're interested in. For this problem, it said, what is the percent composition of nitrogen? So I just focused in on that nitrogen. That's what I did here when I figured out the mass of all that nitrogen. Once you've got your molecular mass and the mass of the element in question, you're going to use your formula, do some calculations, and that'll tell you the percent composition. I'm going to take a little bit of time to erase my wall, and we will try one more problem, and we'll wrap it up for this video lecture. Alright, so we're going to try one more problem that's just a little bit harder than the last one. And I'll tell you that one of your homework problems is set up this same way. So let's take a look at what the question says. It says, what is the percent composition of sodium in sodium sulfate? The big difference from this problem to the last one is that I did not give you the formula. I didn't tell you how many sodium atoms there are, how many sulfur or oxygen atoms there are. I just told you that it's sodium sulfate. So you would need to use your nomenclature rules to figure out what this formula is. We're looking at sodium sulfate. Remember, don't forget what we've learned. We want to take this name, sodium sulfate, break it up into some ions so that we can figure out what the balanced compound might be. Sodium ions. Sodium has a common oxidation state of +1. So I'm going to make this Na+. And then sulfate. Sulfate you'll have to look up on the backside of the periodic table. We wrote all those down. Sulfate is SO4, and it has a -2 charge. So sodium sulfate. Right now these charges do not cancel out. I've got a +1 and a -2. To make these charges cancel out, I'm going to need 2 sodium atoms. So I'm going to make this Na2SO4. This is sodium sulfate. This is the balanced formula for sodium sulfate. So I've got a formula now. That's a good start. Remember what I said on the last problem. The next step that we really want to go for is determining the molecular mass of that formula. So, looking at this, I know that I have 2 sodiums. I would look up the average atomic mass of sodium on my periodic table. I know this one, it's just about 23. I have 1 sulfur. Sulfur is just about 32.06. I've got 4 oxygens. And oxygen is pretty much exactly 16 atomic mass units. I'm going to multiply, and then I'm going to add all of these up to find the mass of the entire molecule. So I've done this in advance. If I multiply these and then added, I'm following my order of operations, I'm going to get a molecular mass of 142.06 atomic mass units. I also could have gotten the molar mass. It would be the same number with grams per mole as the unit. I'm going to stick with AMU for now. So that's a really, really good start. I saw that it was sodium sulfate. I figured out what that formula was. Once I had the formula, I figured out what is the molecular mass of that formula. Now I can use that percent composition formula that I gave you today. So the percent composition, it's equal to the mass of the sodium. That's what I'm interested in, the sodium. So I'm going to use this line right here. 2 times 23, that's going to be just about 46 atomic mass units. And I'm going to divide that by the molecular mass, the mass of the entire molecule, which I've also already calculated. It's just about 142. And then I need to multiply all that by 100%. When I do that, so when I do this right here, oh, I actually did not already work that one out in advance. So just eyeballing it here, it looks like it's going to be about 1/3. This is very approximate. I didn't do this in my calculator or in my phone, and I didn't do it in advance, I forgot. But this looks like it's going to be just about 1/3. So just about 33%. You have to actually get your calculator to get the exact percent composition. I dropped the ball a little bit there, I forgot to do that one. But this is how we would find it. We would take the mass of just the element we're interested in, sodium, divided by the mass of the entire molecule, which I already calculated, multiply it by 100%. That's just to change it into a percentage. It's not going to change the value. And it'll be just about a third. I don't want to sit here and do all that long division. So your homework for tonight is 3 problems that are like this. 2 of them I gave you the formula, and then 1 of them I gave you the nomenclature, and you're going to have to figure out the formula from that. I've got office hours going all this week. I'll be doing them in here most of the time so that I can use my new board. Let's see, if you have any other questions, don't hesitate to email me or ask in the chemistry chat room. Don't forget to be using that too. Have a great week. I hope to see you in office hours. If not, I'll see you tomorrow.